Alright guys, I'm going to record this by myself instead of while I'm teaching, so maybe it doesn't take quite as long and you don't have to hear all the pauses that I have whenever I'm teaching in front of a class. Remember though, you can always pause, you can always rewind, make sure that you understand each piece that I'm going through, and if not, then make sure you either come tomorrow morning and ask me questions, or be ready to ask me questions on Monday whenever we work on the review and makeup work in class. Okay? So first, we are going to write some properties and postulates because remember, whenever we prove, we have to have reasons for our proof. So the first property that we're going to talk about is the transitive property of congruence. We've talked about the transitive property of equality, but that was only in algebraic proofs. So the transitive property of congruence is specific to geometric proofs and figures that we're using to prove. So the transitive property of congruence says if two angles are, well, we're going to say if two figures are congruent to a third figure, are both congruent to a third figure, then they are also congruent to each other. Congruent to each other. Okay? Now for the next four that we're going to write, we're writing 5 total. For the next 4, they all use the exact same if statement. So I'm just going to write that down first, and then we'll write the then for the rest of them. And you won't have to write the if statement down every time. So the if statement for the next 4 is if two lines are parallel and intersected by a transversal, and then we'll finish out with the thens for each one of them. And the first one we're going to talk about is the same side interior angle postulate, and I'm going to abbreviate it as SSI, angle postulate. And I'm even going to abbreviate the word postulate, P-O-S-T. Then, remember, same side interior angles are supplementary. So then, same side interior angles are supplementary. Which I know we know from the definition and from just naming them on the notes from Tuesday, but we have to have it in a formal postulate to be able to use it in a proof. So that's the SSI angle postulate. The next one is the alternate interior angle postulate. And remember, alternate interior angles are congruent. Okay? The third one is the corresponding angle postulate. And corresponding angles are also congruent. And then the very last one is the alternate exterior angle postulate. In the alternate exterior angle postulate, remember alternate exterior angles are also congruent. Okay, so yes, these seem kind of redundant based on the fact that we've already done the definitions and showed what they were, but it's important that we have them in a formal format as well. Okay, so notice or remember that all four of those, the two lines have to already be given to us as parallel, if two lines are parallel. Okay, so that means the given is two lines are parallel. When we are trying to prove that lines are parallel, we have to use the converse of each of these statements. And remember, the converse just means we have to switch the if and the then statements. Switch the if and then statements. Okay? So, sorry, I'm trying to make this where I can work on it correctly. There we go. Finally disappeared. Okay. So we're trying to prove lines parallel. We have to use the converse. We have to switch the if and then. So now let's look at the examples. In example 1, we are given that A is parallel to B and C is parallel to D. That means I don't have to worry about converse. I'm just going to use regular statements. So A is parallel to B is my first given statement. C is parallel to D is my second given statement. Okay, now looking at the picture, we're not assuming anything about measures, okay? Remember, that's what we're trying to prove, is things based on the measures that we're given. So, looking at these angles that are marked, 1, 2, 3, and 4, the only vertical angles that are on this picture are angles 2 and 3. Okay, because I'm sorry, I completely messed up on that one. I looked at the one below. Angles 2 and 3 are not vertical angles. 1 and 2 are vertical angles, so I'm sorry about that. Because these two are vertical angles, what do I know about their measures? They are congruent. Remember, parallel lines, they're either congruent or supplementary every time. Okay, so angles 2 and 3 are supplementary. We know that because, since they're parallel lines, 2 and 3 are supplementary because they are same side interior angles, and that's the same side interior angle postulate. Okay, angle 3 is congruent to angle 4 because those are alternate interior angles, so it's the alternate interior angle postulate. All right, now this is where it's going to get a little tricky. I see that angle 1 is congruent to angle 2, 2 and 3 are supplementary, 3 and 4 are congruent. So how can I change this statement, the only other one that says supplementary, to be this statement? Well, I need that 2 to become a 1. I can do that because 1 and 2 are congruent. I need 3 to become a 4. I can do that because 3 and 4 are congruent. Okay? Since they are congruent, I can substitute in the 1 in place of the 2 and the 4 in place of the 3. So substituting in means I used substitution. Substitution. Sorry, I can't spell today. Okay? All right. Example 2. The first thing I want you to do is mark out the word substitution because it's incorrect in this instance. Okay, I'm going to notice that 2 is congruent to 7 is what I was given, and I'm trying to prove that R is parallel to G, R and G. I'm trying to prove parallel lines, so I know that my very last statement is going to be something about the converse, or a converse of one of those statements at the bottom. Okay? Okay, how do I know that 2 is congruent to 7? It was given to me. How do I know that 2 is congruent to 3? They are vertical angles. Okay? If 2 is congruent to 7 and 2 is congruent to 3, both of these angles are congruent to the same angle, right? So that means 7 is congruent to 3. Maybe it'll work in just a second. Congruent. Close enough. 7 is congruent to 3. Okay? So the property we just talked about at the beginning that told me that if two things are congruent to a third, they're congruent to each other, was the transitive property of congruency. So I'm just going to put transitive POC. Okay? And then the last statement we need to figure out how this part right here tells me that those are parallel lines. Well, if I look up at the top, 7 and 3, let me erase this one. 7 and 3 are corresponding angles, right? One's outside, one's inside. They're on the same side. So that means it's the converse of the corresponding angle postulate, because the corresponding angle postulate said if two lines are parallel and intersected by a transversal, then corresponding angles are congruent. Well, if I switch the if and then on that one, if corresponding angles are congruent on two lines intersected by a transversal, then the lines are parallel. Okay, so hopefully that makes sense. You're going to work on proofs activity right now. Yes, I know that Blue Day got makeup time. Yes, I'm sure you heard that. But you guys will have makeup time on Monday that they won't have as much of. Okay? So you will still have some time to make things up. But remember, if you need to do any kind of corrections or anything like that, it's probably a good idea to go ahead and come in like tomorrow maybe, because you will want to get that done and still have plenty of time before it's due at 4 p.m. on Monday. Okay? So good luck, work hard, and I will see you Monday.